Now we see the remaining part is sigma is equal to n in bracket n suffix e into mu suffix e plus n suffix h into mu suffix h, which equation we get, which is conductivity for a semiconductor, the general equation. Now we'll go to some specific cases like intrinsic semiconductor and extrinsic semiconductor. So in first case, we'll see case 1, intrinsic semiconductor. In intrinsic semiconductor, for an intrinsic semiconductor, the concentration of electrons and holes is equal. So same number of electrons and holes are observed. So we can write n suffix e is equal to n suffix h, which is we can write as n suffix I. It is common term for both n suffix e and n suffix h. So thus the conductivity of intrinsic semiconductor we can write by modify these equation of conductivity, in which there is concentration of electron and concentration of holes which are same. Instead of that we can put n suffix h. So the conductivity of intrinsic semiconductor we can write as sigma suffix I is equal to e into n suffix I in bracket mu suffix e plus mu suffix h. Here sigma suffix I indicate it is conductivity in intrinsic semiconductor. Here the concentration of electrons and holes are similar, but there is a difference between their mobility, because electron having different mobility and holes having different mobility. This equation gives the conductivity of intrinsic semiconductor. Now second case, uh, which is in extrinsic semiconductor. First is n-type semiconductor. We know about n-type semiconductor. For n-type semiconductor, the concentration of electron is much greater than the concentration of hole. That is, n suffix e is too much greater than n suffix h. Because we know in n-type semiconductor we are doping a pentavalent impurity, and each atom there is one electron will be excess. All these excess electrons in each, the total concentration of electrons is too much greater than the concentration of holes. The majority of charge carriers are electrons, and contribution of holes is neglected due to very small number. So this term of concentration of hole will be neglected. Thus the conductivity of n times semiconductor we can write as sigma suffix e is equal to n sigma suffix e is equal to e into n suffix e into mu e. Here at denominator, at suffix e, it is indicate that concentration of electrons is more. In some cases we can observe the sigma suffix capital E, capital N, that N will be notation of n-type semiconductor. In some cases instead of N, E also used. So sigma is equal to E into N suffix E into mu suffix E, which is the conductivity of n-type semiconductor. Similarly, we can write the conductivity in p-type semiconductor. So we consider case number 3, p-type semiconductor. For p-type semiconductor, the concentration of hole is much greater than the concentration of electron, that is n suffix h is too much greater than n suffix e. So the majority charge carriers are holes and the concentration of electron is neglected due to very small value of concentration of electron. So I am repeating this again. In p-type semiconductor, the concentration of holes is too much greater than the concentration of electrons. Why this happened? Because when there is sharing, it takes place in semiconductor, that time trivalent impurity is used, and that trivalent impurity produce in each atom one hole. So in large scale, we can observe the large number of holes will be available in p-type semiconductor than electron. So we can write the conductivity of p-type semiconductor as sigma sigma of a p-type semiconductor, that is conductivity sigma suffix h is equal to E into n suffix h into mu suffix h. This E is the charge, where these small e is the charge, n suffix h is the concentration of hole, and mu suffix h is the concentration of, or you can say it is mobility of holes. So this is about the conductivity in semiconductor, intrinsic semiconductor, as well as in extrinsic semiconductor. Thank you.